NASA announced Thursday the most luminous galaxy ever discovered is cannibalizing not one, not two, but at least three of its smaller neighbors, according to a new study published in the journal Science and co-authored by scientists from NASA's Jet Propulsion Laboratory in Pasadena, California. The material that the galaxy is stealing from its neighbors is likely contributing to its uber brightness, the study shows. The agency adds, the galaxy is by no means the largest or most massive galaxy we know of, but it radiates at 350 trillion times the luminosity of the sun. NASA goes on to say, new observations reveal distinct trails of dust being pulled from three smaller galaxies. The trails contain about as much material as the smaller galaxies themselves, and it's unclear whether those galaxies will escape their current fate or will be completely consumed by their luminous neighbor.
A companion study about W2246-0526, published on November 14 in the Astrophysical Journal, provided the mass measurement for the supermassive black hole at the galaxy's center, 4 billion times the mass of the Sunday. This mass is large, but the extreme luminosity of W2246-0526 was thought to require a supermassive black hole with a mass at least 3 times larger, according to the paper authors. Solving this apparent contradiction will require more observations.
In other words, the mass is well, I just got through saying. Okay.
NASA's Jet Propulsion Laboratory in Pasadena, California, managed and operated WISE for NASA's Science Mission Directorate in Washington. The spacecraft operated until 2011. In September 2013, WISE was reactivated, renamed NEO-WISE, and assigned a new mission to assist NASA's efforts to identify potentially hazardous near-Earth objects. News media contact Calico Field Jet Propulsion Laboratory, Pasadena, California 626-808-2469 cala.e.cofield@jpl.nasa.gov Charles Blue NRAO Public Information Officer 434-296-0314 C Blue @nrao.edu. The supermassive black hole at the galaxy's center, 4 billion times the mass of the Sunday. This mass is large, but the extreme luminosity of W2246-0526 was thought to require a supermassive black hole with a mass at least 3 times larger. We use optical and near-infrared spectroscopy to observe rest UV emission lines and estimate the black hole mass of WISE J22460752634.9, W22460526, at Z equals 4.601, the most luminous hot, dust-obscured galaxy yet discovered by WISE. From the broad component of the MG2 2799A emission line, we measure a black hole mass of log, MBH/M, equals 9.6 plus or minus 0.4. The broad C4 1549A line is asymmetric and significantly blue-shifted. The derived MBH from the blue-shift-corrected broad C4 line width agrees with the MG2 result. From direct measurement using a well-sampled SED, the bolometric luminosity is 3.6 times 1014 L. The corresponding Eddington ratio for W22460526 is lambda ed equals LAGN/L ed equals 2.8. This high Eddington ratio may reach the level where the luminosity is saturating due to photon trapping in the accretion flow and may be insensitive to the mass accretion rate. In this case, the MBH growth rate in W22460526 would exceed the apparent accretion rate derived from the observed luminosity.